Hello and welcome to buildingSMART webinar. This webinar is part of the buildingSMART Virtual Summit for Spring 2022. Thank you for joining. My name is Laura and I will be your moderator today. Today's webinar is titled Sustainability Energy Management Room Introduction. Our speakers are Trinidad Chardin-Segui and Bertrand from Schneider Electric, Christian Frey and Oliver Lebherz from Siemens, and we also got Richard Kelly from BSI. This webinar is scheduled to last 1 hour with a short Q&A at the end. The webinar is being recorded and will be made available in the replay section of the event within 24 hours. Before I hand over to our speaker, I would like to remind you that your phone line will remain muted for the duration of this webinar. If you have any questions or wish to make comments, please use the specific chat box in the control panel on the right-hand side of your screen. I would also like to bring to your attention that buildingSMART is committed to ensuring that participation in the development and standards is unrestricted, and the process for their adoption is transparent, and standards that are developed do not favor any particular provider and are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct. Now I would like to hand over to Richard Kelly, who will be presenting all our speakers.
A new room. I announced on Monday that we have a new room at buildingSMART International, which is a sustainability energy management room. The room has a fledgling steering committee, who I'm going to introduce to you. The steering committee of our rooms, or our specialist domains, their job is to set the mission and the vision of the room and to set the medium-term roadmap, the plans for how we're going to respond to the industry needs in this particular domain. So this fledgling committee is made up of members from Schneider Electric and from Siemens. I'm going to introduce to you Bertrand, Oliver Lebherz, Christian Frey, and Trinidad Chardin-Segui. And I want to give a special mention actually to an old friend of buildingSMART, which is Tahir Sharif, who many of you may know, and he has been the catalyst from within Schneider for getting this new room off the ground. So without any further ado from me, I'm going to now hand you over to Bertrand and Oliver, who are going to take you through a presentation, and then we'll come back onto the stage and have a discussion and take questions. All right, thank you very much. Over to you, Bertrand.
Okay, thank you, Richard. So hello, everyone. I am Bertrand from Schneider Electric, and I am very happy and proud to introduce to you today this new room about sustainability and energy management in the building. And I have my friend from Siemens, Oliver, who I let present himself to do this with me. Hi, Oliver.
Hello. Hi, Bertrand. Hello together. My name is Oliver Lebherz, and I'm from Siemens. Thank you for the introduction, Bertrand. I'm happy to be here, and yeah, I'm looking forward to work with you in a new, interesting topic. Yeah, and also in the next hours for an interesting presentation. Thank you.
Okay, so let's go into this subject and why did we propose this room about sustainability and energy management. So basically, the ambition of that room is to accelerate the digital transition towards buildings that are efficient in terms of energy or electrical power consumption, that are sustainable and resilient. For this, it's about providing the ability to design efficient and sustainable electrical installation, electrical network in the building. So to improve the toolings, to improve the data model, we will go through this into more detail, bringing some capacity to change the design, taking into consideration the new energy landscape, to be more optimized during the design, but also to continue in transferring the information during the building and operation phase. It's about giving the capacity or the ability to simulate the power consumption. It's nice to know that you have consumed so much during last month, but what is even more important is to be able to say, oh yes, it's good, or oh no, it's totally out of consideration. And last but not least, connecting the real building to a virtual data model is something that most of you in the building environment is aware about. So that basically the why about this room. Anything you would add, Oliver?
I totally agree with you, Bertrand, of course. And maybe some additional perspectives could be that we need to regard as a different phases of a building, not only the planning phase, but also the execution phase, and also, of course, the operative phase. And that's what we want to regard maybe also in the working room. But I totally agree with you. We have to push the electrotechnical trade in the building, and especially in the BIM working method. And that's what we try to do in the next weeks, months, maybe also years in the working group. Yeah.
Absolutely. Absolutely. So if we look a little bit about the situation and the context in where we are, more specifically, as Oliver stated, on the electrotechnical trades, so the electrical contractors, the panel builders, the different engineering in the energy domain. And if we look at the situation during the 3 phases of the planning or the design, the build, and the operation and maintenance, like we have more generally in the construction, we all know that we face, or that the trades are facing, a lot of inefficiency at any stage. Inefficiency in the weak, not to say the lack of coordination between the teams and the companies, inefficiency in the transferring of information. There is a lot of recopy with mistakes and time lost, inefficiency in tracking the different evolution. So that is something that is pretty common to our building industry, but it's even more stringent and important in the electrical trades. I would say that the steps that have been done in the general construction are still lagging in the electrical domain. If we look about compliance, not only do we have to face the challenge of the global warming and to design new buildings that are efficient, but there are new standards, new regulation that our specifier designer must be coping with. And the challenge is also to integrate new energy landscape, I would say, features or sources, like how to integrate a PV panel, how to integrate batteries, how to integrate a smart grid, and how does it impact the general architecture of the building. So we are in a situation where the business, the trades were not always the most efficient in collaboration, but the compliance are more and more, I would say, strict. And due to the transition of new energy landscape, due to the transition of digital, I would say the step is even more important. So we are in a situation where we have a lot to do in terms of efficiency and alignment. What else could we say, Oliver?
Yeah. You have mentioned so many different aspects. Are completely right. Yeah, and I think we need to push the awareness that the electrotechnical trade, that there are so many different roles are integrated in so many different companies, and all these companies needs to work together closer and closer in the future. And that's results on the basis of the challenges in the market, in the infrastructure market, but especially, of course, also of the BIM working method. And so that's a lack of coordination between the teams, yeah, but also the compliance topics which you have mentioned. Yeah, in a nutshell, we need to push the BIM working method, especially in the electrotechnical trade. And I think we have too much space for improvement, yeah, and that could help to push a building, to regard also the electrotechnical trade.
Okay, so how can we address this challenge? And that is what is the ambition and the vision of what we want to bring and address into this sustainability and energy management rule. So we believe that the very first thing we must propose is a data model to support the description of an electrical network. As we often say briefly, a kind of IFC electrical. So a true data model, something digital, so that the different software can exchange information around the description of the data model. This to provide, as the IFC did, efficiency in the design phase, improve the collaboration, avoid all the recopy and time saving. So a true data model around electrical network description. And I don't think such a data model, myself, I never saw something like this. Did you ever see one, Oliver, in your environment?
Not really, to be honest, yeah.
Yeah. So that's the first challenge. The second step is, as we address the efficiency, the energy efficiency, I mentioned earlier, we need to be able to propose process, methodology, maybe some model we will define in order to simulate what is the electrical power consumption. On the image that we have here on the right, the situation would be something like this. Let's imagine you have a smart meter that has consumed the last month's consumption, 1,234 kilowatt last month. What we need to be able to say is first, okay, where is this meter in my electrical network? So that is one purpose of the data model, which is to be able to locate, I would say, functionally speaking, okay, this meter is here in the network, and it is metering the HVAC consumption, for example. The link with the BIM model is obvious because it will be able to say, oh, and by the way, this boiler is here on the roof of the building. So the link with the physical IFC. But then what is also important is that the 1,234 kilowatt of last month, is it good? Is it totally out of what we had forecasted? So we need a kind of forecast model, the GPS of the electrical consumption to know if we are on the right track. So how to build such a model, how to share something is the objective. And the third point is around the sustainability. Not only should we take care about, I would say, the live consumption of an installation, but also should we consider that the architecture, the choice that are being made very early in the design phases of the electrical installation have been the optimized one, that the network is not oversized. Because we know that most of the impact on the CO2, if I just take the CO2 as an indicator, are first coming from building. Building is a major contributor of that, and the electrical part is important in there. And it's 50% in the design and build phase, 50% in the operation phase. So not only it's about the consumption, it's also in the design and build phase to make sure that all this is optimized. So these are basically the three pillar of what we want to address in this room. And maybe Oliver can repeat or elaborate a little bit more of what we have, and I let you continue on this one if you are okay, Oliver.
Yes, of course, would be a pleasure. Thank you. So in a nutshell, what we try now is to define a digital twin of the electrical trade based on the IFC standard, where also different parts and substrates of the electrical trade, could be implemented, yeah, and so that we have at the end a digital twin of the power distribution system in a building. Yeah, and afterwards, if we have the digital twin of a power distribution board with all the substrates, for example, the busbar trunking system, the power distribution board, but also the final distribution boards, or maybe also the cabling in the final distribution circuit, then we can start the simulation. Yeah, the simulation, what Bertrand has mentioned, simulation of energy monitoring, for example, but also maybe during the operative phase of building, for example, the predictive maintenance topic. Yeah, so that we have at the end no breakdown of the power distribution system. Yeah, and that's in a nutshell what we try to push in the future. So a digital twin of the electrotechnical trade in a building, but also to start the simulation on IFC basis, yeah, but also to simulate the behavior of the power distribution system in a building, the simulation of energy monitoring, but also to regard all the maintenance aspects maybe.
Yeah, absolutely. So at the synthesis, three pillars we should have in this room. A digital model that we propose to call the normalized electrical model, energy on one hand, on the second pillar, and sustainability on the third pillar. If we look if we zoom on one of these pillars, which is a normalized electrical model, so this normalized electrical model, the ambition is really to set up or to improve, because we bring something to the community, but to have a data model that is here to describe all what is needed to describe an electrical network, an electrical project, in order to enable first interoperability between different tools. So we can think about having a first draft of the network that can be done in a beam authoring tool, while designing the building and placing the different equipment. The global electrical network layout or architecture can be designed, but then it can be transferred to some more electrical dimensioning or electrical calculation specific tool for really dimensioning the electrical network, and then going back to address the cablings inside the building, and then moving to a panel builder who will have to address really a switchboard and the device in the switchboard. So what we face is that we have a lot of different software, and that we need a lot of interaction and integration between, I would say, the BIM environment and the electrical environment. So the challenge is interoperability of all this change. That's the first objective. The second objective is also to enable what we would call in the BIM environment, the level of detail or the level of information. An electrical network as a beginning can be just a block diagram, and later on a riser diagram, and later on a single line diagram. And then at the end, it's every contact or every pole, every phase that needs to be wired. But all this will need to be improved and described by this model. So that's why in terms of features or facets, we must be able to not only describe the big objects that are today in BIM, but going deeper into the description of the products and functions that we have around the electrical network, describing a network topology. An electrical network topology, of course, is the core of it. Managing the specification of the information is also something transversal. And then going into the different facets that can be the layout of a switchboard, the physical models, which is somehow the capacity not only to have a BIM object, an IFC model, or a specific object of a switchboard, if I take this as an example, but also if we look inside, to have the capacity to describe how the inside is assembled. And an electrical network needs to be controlled and monitored, as we mentioned earlier. So we must also address these other facets. So these are the different facets that we have to address in the NEM model. That's another image showing that here are all the facets of an electrical installation. Anything to add that I would have missed so far?
No, I think you have described each aspect which we need to push, and especially as the NEM model is a basis for to describe everything and to work with at the end in different phases, in different roles, in different softwares. And yeah, I think you have described everything very well. And I think we have so much potential now, especially for the electrotechnical trade in the BIM working method. Yeah, and that's why we try to push all the activities now in the NEM model.
Absolutely, exactly. And I think for the audience, you start to see, or at least it's what we hope that you start to feel now, is that why we bring this model into the IFC and BIM, because you see that there are a lot of dependency on one hand, because the network is within the building. There is question about layout of a building. I take the traditional example. One core thing in the electrical network is the length of the cable, but the length of a cable can only be found if we have the layout within the building. So we cannot work one without the other. And then the different equipment end up being object in the building. So that's also the link with the IFC. And then if we look at the product description with the BSDD, at the electrical functions, communication and control, all this is consistent. So that's basically the objective. I will switch that one. So that's to say that this NEM as a new digital model not only is a part of the, I would say, of the BIM environment in the IFC, but also to the product description. There are other standards or other classifications that are widely used in the electrical trade and electrical distribution that we must work on some compatibility. I'm not to mention them, things such as E-Class or ETIM as a format, and of course the buildingSMART data dictionary. So working on the alignment of all these classes within BSDD is absolutely essential. And we know all here around this conference how much the alignment on taxonomies and dictionaries is the base. If we are not aligned on dictionaries, it will never fly. So that's the first thing. And then in the general environment, the building description with BIM is one, but we should not also forget that a building is somehow connected to a grid, and that this grid is managed by the utilities. They have also some standards like the SIM or IFC or IEC 61850. So there is also some compatibility to address in that. So that's about, I would say, the dependencies that we have. Not to forget what is also in terms of sustainability existing, such as GB, XML, and things like that. So I would say the ecosystem is here and needs to be worked out. So that's one part of the challenge, interesting challenge that we will have in this room.
So at the end, we have so many challenges, but so many possibilities. Yeah.
Sure.
And what we try is to use all the possibilities we had already. Yeah. And the one possibility is based on the IFC structure, of course. Yeah. Maybe we need to extend a little bit the IFC structure, especially for the electrotechnical trade. Then we have, of course, the BSDD to have right communication between different rows, different software packages, but also during a phase, the different phases of a building. Yeah, so we need to find the right communication between the different rows, software packages, and of course, at the end, we need to regard the power distribution system in a context of a building, but not only of a building, but also at the end of a grid. Yeah, if we regard, for example, some power consumptions aspects, yeah, or simulations. So I think that's a very interesting topic and a topic which is absolutely necessary for a building, yeah, because the electrical network is a backbone of a building. Without power, you can't do anything in a building.
Yeah.
Yeah.
Absolutely. So here we are. This is basically the vision, the picture. And now the request is we are looking for contributor to participate to this room. As Oliver just said, we have a lot to do. We have an interesting challenge. We have different facets. Electrical is, of course, electrical and energy is at the core, but it's about software design. So if some CAD editor are welcome. It's about the building and end user. I was listening to some other best practice in the IFC and looking at IFC rails or things like that. The contribution of, I would say, end user, if I can call them this way, was absolutely a key point in the case of IFC rail. Should we benchmark this for this sustainability room? So if we have some people representative of the building real estate, if we can say, you are mostly welcome, and many other, we are awaiting you and expecting you to this nice journey that we have in front of us. And that's about it for the introduction, the teasing introduction. I hope it was teasing enough. Now I let the floor back to Richard and the panel.
Thanks, Bertrand and Oliver. That was great. And it's just nice to see such a great collaboration between the two companies. It's true to say that neither of you had met each other a few short weeks ago. That's the case, isn't it?
It is. Sorry.
Yeah, that's okay. You need a drink after all that. I mean, you've made it very clear that the vision and the mission of the room is emerging, and you know the breadth of what it's going to do is very well explained, and how we want to constrain the boundaries of it is also well explained. Let's have a discussion about some of the things that you've raised in that presentation and go into it in more detail. Let's start with, I'm going to start with something quite specific actually, which is the normalized electrical model that Schneider Electric have brought to the party. What's missing in IFC at the moment that requires the NEM to exist?
Yeah.
Bertrand, maybe you take it first.
Okay, I can take it first. So, as you say, on one hand, we are bringing, I would say, a backbone for this model already existing that we use. On the other hand, we have the IFC, and I can imagine maybe 3 points of it's not really improvement, it's alignment or complement in the IFC. If I'm thinking about an electrical network, I briefly stated it earlier, is a representation of a diagram, okay? Like a building is based of, or a campus is made of building, which is made of floors, and that is made of zone, and that is made of rooms. We have some kind of similar hierarchy in the electrical domain, but in the design phase, it starts with general block diagram, and then it might be with equipment, like a riser diagram, and then into products that are just generically defined, and then into specific products that have all the accessories for control and communication. So a first improvement is around the definition of these subjects, and that can be also the link with the BSDD. And as I said, also in the alignment and the enrichment of the BSDD or the IFCs with all the properties, the P sets regarding all the electrical functions and products that we must have. And the other area that needs the third, so that would be the second one in the BSDD. The third improvement is, I also mentioned that we have big equipment like a switchboard, which is today relevant to have as an object to be placed in the building together with a transformer and so on. But inside this switchboard, which is never twice the same, by the way, we have all the control gear and switch gear, the protection devices, the gateways, and it's important to know the physical relation between where these products are installed inside the switchboard and what they control or what they supply in the building. So that's also about the third aspect, the geometrical aspect to be worked. And here, my gut feeling is really about working on the level of integration of this kind of information. I think we cannot really think of having a beam authoring tool, can be Archicad or can be Revit, and designing a switchboard with it. I think it is not relevant, but we must make sure that we can share the information. Basically, that's how I would see it.
Okay.
May I add something?
Chris, yes, please.
Yeah. So the question was, what's missing with IFC? I think with the sustainability and energy management room, we try to bring IFC and BIM to the next level. Yeah. So far, BIM and IFC has mainly focusing on standardization of design and the construction phase. So, I mean, with facility management and the fire safety room, we have a first step into operation. But the operation is really important because 80% of the building infrastructure, building and infrastructure life cycle is in operation. And we need a regular adaptation to new requirements of use. And for example, today, forced by COVID, we change our building environment, especially the office environment. We have e-mobility coming up, we have photovoltaic and so on. So this is really important, especially for the operation phase, that we are also flexible in the electrical design. And today, as I see, a main focus is still on the thermal improvements with the Energy Plus tool and so on. And of course, energy and efficiency of thermal energy is important. But however, without electricity, a building will not work. Therefore, the design of an efficient and sustainable electrical network in a building is similar important for efficient operation and future adaptation on upcoming requirements. And everybody encourage, if you have electrical DNA in your blood, just join this room and help us to standardize also the electrical part of the for the operation of buildings and infrastructure.
Nicely said. Thanks, Christian. So it's clear then that one of the major aims of the room is to get open digital information available so that decisions can be made about the electrical network in a building to allow that building's management, energy management, to respond to needs, whether they be emerging needs, new, or whether they are existing parameters that the building operates within. Trinidad, I mean, you are the technical leader for the room, and you will be sitting on the Standards Committee Technical Executive, which is the central technical body of buildingSMART International. Have you got any considerations about the NEM, which is, obviously something you're very familiar with, and perhaps its interaction with the buildingSMART data dictionary?
So for me, it's a very good question, because today the objective is clearly to interlink the different disciplines and the different efforts that already exist. So it's not to replace, it's to interlink and to make the exchange and the interoperability easier. So on the different dictionaries, the objective, as you understood, we mentioned that already, the BSDD and all those efforts, but at the same time, we know in the electrical environment, we used to have standardization bodies such as IEC. So the objective is to make these two worlds working together to produce this interconnection and this interoperability. So for sure, we need much more this alignment and this pivot kind of format than replacing all the huge effort and what all the standardization body have made. And the reason it's clearly to do that. The second thing is, if I look at my experience in the electrical world, a lot of things today of how I'm choosing, building my electrical models are managed by those international bodies, but most of the time they are not able to help us to build on the software environment how to structure and how to model and how to use it. They are starting the efforts, but I think we need to bring together the two approach to make it much more efficient.
Nice. Okay. Now we've got the word sustainability in the title of the room. What do we think we're bringing new to the Open BIM agenda with this room? And who wants to talk about how it's going to have an impact on the sustainability agenda?
Maybe what we also can add, that the electrical power used but also generated by buildings is an important player in the smart sustainable grid in the near future. So a building will be a prosumer, and for this, the sustainability is should be part of the building, of course, and need also be represented in the electrical network.
And maybe to complement what we can look at in the historical way of building, designing electrical system. I would say in the building environment, most of the time the electrical system was designed to support the worst cases on the usage of the electrical power in the building. But today we are facing the sustainability, and then to work on a much more optimal design. I will say by optimal design, the capacity to be the just enough power consumption by the network itself, and for sure supporting all the activities of the building is designed and the purpose of the building. And doing this work today, if we are looking at the different discipline of design in the building, we are not doing that today to make this full optimal design. And one of the issues when we look at the electrical area is that as we do not have standard to exchange around the electrical system, it's quite impossible to have this interaction between the different disciplines and then to start to have this optimal design on the power consumption of the installation itself and how to help to build an optimal power consumption also in the building itself. So here, the NEM have clearly this objective to support this interaction between the different disciplines.
And maybe also what we could add is one of the intention or objective of this room is if we could unleash or unlock the creativity of some software editors to propose some new tools, new simulation to design differently a building, taking into consideration the power, the electrical network, and the construction. That is also something we can dream about. We don't know what smart ID we can what smart ID can pop up tomorrow if we enable the capacity to really see all the things together.
Okay. And what is it, regarding sustainability and efficiency that's additional in this room, or going to be in this room, that's not already addressed on the market, would you say? Oliver,
I think the challenge is to bring the things together. Like I often said in our discussion, preliminary discussion, I have been in different working groups of buildingSMART or other about building and efficiency, and I was always how can I say, disappointed by, we speak of the core and shell. Is my building thermally a good building or not? But what about the link with the consumption, the simulation, the behavior of the consumption, and how can I change my control of the building or of my different operation depending on the construction of the building? I take an example. Maybe in terms of efficiency and sustainability, it would be smart to say, oh, I undersize a little bit, or I know that there is some latency in the temperature decreasing of the building, and I can anticipate that, and I know tomorrow I will have a shortage of energy. I overheat 2 degrees in the morning, and I shut off in the afternoon, and the comfort will be safe. Same, but the impact on the energy will be strong, and maybe I can even sell this capacity. So there are many things we can think, but we must bring the capacity to simulate. So to answer clearly your question, is really bringing the different trades, the construction, the electrical, the control, all together.
So do you see that there's an opportunity here for when people are making capital expenditure decisions about the design of the building and the amount of thermal insulation of the building, they're also taking into account the operational expenditure decisions about how much energy the building is going to use over its life, and getting feedback from the electrical system, information from the electrical system, able to say, make the right decisions or better decisions about how to build the building as well as how to operate the building, so that we're taking a total expenditure over the whole life of the building into account.
Yeah, I mean, today when you plug in a device, you expect that there is power and the device is working, and well, everything is done that this is possible, and very often oversized. And also what we not do use today is really also the information that comes from the electrical network. As I said, if you plug in something, it's like is there an occupancy of a person, or is it an occupancy of an electrical vehicle or whatever? All this must be taken into account, and with the computer systems, artificial intelligence, all the stuff, we will also be able to predict what's coming up. What do I need? Let's maybe also to store also on electrical energy. To be prepared, as you just said, we see thermal energy. When you overheat a building, normally in the morning, then everybody opens the window, then the heat is gone. So this is all not sustainable, and we need all this information in order to make sustainable decisions. And for this, we need more feedback also from the electrical network, in conjunction, as Bertrand said, with all the other stuff, with the environment, with the operation, and all this that comes together.
Okay, all right, good. So the aspiration is clear. Thank you. Now, when the room gets fully started, the room is going to oversee projects. It's going to oversee work that's going to be done in order to generate solutions and new standards, no doubt. In terms of what needs to be done, how much of the normalized electrical model already exists, and what else do you think the room still needs to do with it in order to take it forwards?
Okay, so we already have an in-house in Schneider model to describe an electrical network. But as it was done for us, I would say, and between our software, the main principle, I would say, is here, the one I described earlier, the capacity to have different things that can be a device or a transformer, and to link things together. It's existing in the NEM today. It's existing in the IFC. There is probably some alignment on the semantic and maybe some improvement on the technology to be used. I don't want to bring some debate of technology or expert about semantic model, non-semantic model. That's not the objective, but so there is something. The first improvement that needs to be done, which is not open enough inside the model we have today, is I would say the classification of products and functions to be fully agnostic, and that we all agree on a dictionary, a taxonomy of devices, breakers, contactors, relays, all the electrical stuff, and the dictionaries of properties. That is probably the very first alignment, and together with the BSDD to be done. Then there is also probably, but to be decided together, some improvement to be done into the technology as we are in the digital environment. The model we have today was done some years ago. It's still based on an XSD schema and XML exchange. If we want to be robust proof, we can probably reconsider that, and also making it more compatible with the technologies of the IFC. So that's also I would say the basis here, but the openness must be improved, and the alignment needs to be worked out, and enrichment, because it's just a starting base.
Okay. So Oliver, can I bring you in? I mean, have you got a view about the integration of the NEM with the IFC and how that might work?
Yes, of course. So I totally agree with Bertrand, of course. At the beginning, we need to describe also the devices. Yeah, but that's really the beginning. Afterwards, we need to describe the network. And today we have already existing workflows and maybe also software packages. Each electrical planner is already making an engineering for the dimensioning and so on. But it's not described in an IFC structure. Yeah? And so the target would be at the end, after we have described the smallest devices, also the functions and the network of a power distribution system within the IFC structure. Yeah? And so at the beginning, of course, we need to regard at the beginning the planning aspects, so dimensioning of a network, but also at the end, we need to regard the execution phase, the construction phase, but at the end, especially the operative aspects. And the operative aspects are more or less the functionality of the devices at the end. Because on the basis on the functionality of the devices, you make the simulation. Yeah, you get also real-time values of the MCCPs, for example, to make a calculation of the network, or you get also at the end in a building management system in the operative phase the real-time values at the end in an for the predictive maintenance aspect. If there's an alert, for example, yeah, and so I think we have so many advantages if we regard all these aspects and bring the different rules and working methods together. And that's the target at the end of the IFC activities and the BIM working method for the electrotechnical trade.
Okay, very good. Anybody else want to comment on that? While you're thinking about that, I'll just have a message to our audience to say, because I know there's several dozen people listening to this. If you do have a question for the panel, we have a few minutes left. You can ask the question in the chat and we'll put it to them and see what comes back. We're, I mean, obviously we're looking to expand the room steering committee. At the moment, the steering committee is made up of just Schneider Electric and Siemens. We do want more members from the industry into the steering committee. The BSI process actually allows for the standards committee executive to appoint people to the room steering committee when it's its early stages until we get the room properly running. And therefore we will be reaching out to various people in other organisations that are members of buildingSMART. But if there's anybody that's particularly interested in this room and its mission, its vision, and getting involved in the activities that it's going to be overseeing, then please let us know. Alternatively, it may be that somebody's got an activity proposal. They don't want to be in the room steering committee, but they have got a specific requirement that they want this room to be dealing with. So you can put forward an activity proposal, and we have a template for doing that, which can be found on our website if you search for the BSI process in the early stage of the website, in the About section. Okay. Well, no questions coming in from the audience at this stage. Is there anything that anybody else wishes to comment on? Any final comments from our panel about this room and your aspirations for it? Okay, all right. Well, I think we've given it a very thorough going over. I think it's been very clear what the intention is, and I'm looking forward very much to working with everybody.
Just a question, we don't see how many people were attending, so just to have a live taste, how many do you know how many people attendees did we have?
I think we had 31 at the beginning.
Okay.
Which isn't bad for a session of this sort in the room. If we were live, we'd have that about, we'd have about that many people actually physically in the room with us.
The message is join us, let's have fun.
Yeah, join us.
I foresee that this room will be as popular as the infrastructure room in time.
That's a challenge. That's a challenge.
So, yeah, very good. I think for buildingSMART, it is also important, as I mentioned in the beginning, that we extend the IFC and BIM, open BIM, especially also to the operation phase of buildings and infrastructure, and for this also this electrical sustainable and energy management room is looking forward to work with other players in the market in order to get this standardized and as an open standard.
Indeed. We've had a comment in from one of our viewers from, there we are, from Marcel Merbeland. Thank you for the amazing discussion. Thank you for the feedback.
Thank you.
Thank you.
It's a little difficult just standing here talking to a machine because we're all in our homes or our offices, and we'd all love to be together. And Stefan Joud has made a nice comment as well.
Thanks,
well,
Stefan.
It's been lovely talking to you all. As I say, I'm looking forward to working with you all in the growing of this room and spanning the, creating the agenda and taking it forwards. All right. Thank you, everybody.
Thank you.
Thank you.
Bye-bye.
Thank you.
Have a nice
Bye-bye.
day. Success. Bye.
Bye-bye.